This video and associated handout is on creating public MS-MS libraries in NIST format. It's part of a full course on NIST 26 with newly integrated deconvolution library searching for LC-MS-MS, and here is the link to my website. This was written for NIST 26, but also while I will be substituting it for the NIST 23 Part 7 video handout that I had previously on my website. Two public libraries, Mona and MS-DAL, are currently available on my website in NIST format. It includes MS-DAL PAUSE, MS-DAL NEG, and Mona LC-MS-MS. Together, there's 500,000 spectra with greater than 150,000 associated structures. See the link to download it. Libraries are described in detail in this link. This is made available as a basic resource. These libraries will not be routinely updated, thus the user might want to create their own. A Mona library conversion is demonstrated in this video to help you in that, and there's a lot of extra information available in the handout and vice versa, so you might want to look at both of them. Also, NIST has a list of others that could be converted into NIST format that they've supplied, and you can see this full list of sources of free public MS-MS libraries on my website resources. See the link. Originally, I downloaded Mona LC-MS-MS Spectra as a group of approximately 153,000. You can see the screenshot below. Unfortunately, Mona has now combined with NVIDIA 180, and this change was made in mid-July 2026. You can see a ChatGPT summary on the next slide of what this means to users. The file is very large, 2.7 gigabytes, and cannot be opened by most Windows programs. One might be able to create a NIST formatted library from the SDF file using lib2NIST, but I didn't try. But NVIDIA are enamine real space drug-like compounds, so it may contain many synthetic structures that would not rarely appear in routine environmental and other samples. Thus, I decided not to try to convert this file. On Windows, the easiest approach is to use PowerShell to stream through this file one record at a time and write a new SDF without NVIDIA.180. That way, Windows never loads the entire 2.7 gigabyte into memory. You would have to figure out how to write a script for this in PowerShell, and ChatGPT can be a big help there if you want to try it. The approach described from my prompt in ChatGPT, but I decided, like I said, not to attempt this. The MS-DAL could be created with lib2NIST, but with no structures. And here's the Mona link and the MS-DAL link. Here's the ChatGPT description of this new Mona combined library, and I'll leave that to read for yourself. Again, it has a lot of new spectra, but in many cases, I don't think they'll be generally useful to most people, so I will not try to do that for you. But in your case, it might be useful, so give it a try. Here I compare the different libraries, the NVIDIA, the Mona traditional entries that I had before, MS-DIAL, and NIST MS-MS. In general, MS-DIAL is a metabolomics, lipidomics heavy. Mona is very broad community collection. NVIDIA 180 is synthetic drug-like chemical space. And of course, NIST is a very broad and highly curated reference library of very high quality. For this demonstration, I will use this all LC-MS-MS Orbitrap of about 159,000. These two might be generally useful to you, and you can load them down in separate libraries, and NIST can search many libraries at a time, so the number of libraries you use in your searches is really not a concern. And so here's the steps in the conversion process. It's the outline, and I will go through the steps in the video, so I won't go through this outline in detail here, but it's here to refer to. I always use the newest version of lib2NIST, and I couldn't figure out originally how to tell what it is. We have to click on the little icon when you open lib2NIST. It's in the program list for the NIST software that I downloaded, and go about lib2NIST. You don't change any of the parameters really to do this, but it is critical when you're doing MS-MS spectra library conversions that you click this. It's different for electron ionization. And after you do that and select what you want to convert, you just convert it. So we'll go through that in the software. After you're converting from SDF to NIST formatted libraries, you have to turn the libraries into an index that can be searched. You will be able to display the structures with your search results, but if you decide to do a structure search, it will not work until you re-index this. And this is the same case for individual libraries as you add entries. Every time you add an entry to your user library, you have to update this so that that additional structure will be included in the index for searching. And it'll usually come up when it needs to be updated, and it'll show in lowercase anything that needs to be updated, and you just say build. There's one problem I had when downloading some of the larger libraries. There were some problems with structures. If they don't have structures, this will not be a problem. So like for the MS style, it would not apply. But for some of the libraries, it wanted you to say there was some problem with the mole file importing, which it really didn't seem to hurt it when it finally converted it as far as displaying it. But it was kind of painful and took a long time to sit there over 15 to 30 minutes and every time the thing came up, it'd say, okay, okay. So this is a way that you can write a script. It's using this software here, auto hotkey. So I found that very useful, and that's what I used. So after you get your library created, we'll do some tests. I always think it's very good when you convert a library to test it. And we'll test several different modes, and even including a structured search. So that's pretty much the introduction and all the slides. So we'll go into the software and actually demonstrate some of these processes. So the first thing you'll need to do is to go to the website for Mona and find the spectra that you want to export in SDF format. The SDF includes spectra and structures, and a lot of the files like MS Style do not offer the structures, and you have to download them in MSP format. Here was the big file I said that I don't want to download, so for demonstration purposes, I'll download this one. So I'll click on it, and you can see MSP format we don't want because that's only the spectrum. We want this FDF format, which I downloaded. I downloaded to my website. Actually, not to my website, but to my disk drive. And so we can go look and see. It should be here. That's Mona export all LC-MS MS orbitrap-sdf.zip. And the next thing you need to do is, of course, unzip that to your disk drive. So I just unzipped it and put it at the same level on the download. So that's pretty straightforward. But then after that, you need to open up lib2nist. And to do that, initially, you go to Programs, you come over to the Program Group, and that's the 26 download there, and open it. I've already opened it, so I won't open it again, but that's how you initially get it open. And now I need to add some things to it. So you can see here, I went and found, this is at the downloads, you have to navigate to it to find the SDF file that I need to convert to NIST format. And I select it and I say open. Now the other menu was on my second screen and it wouldn't let me drag it over until I did that. So you need to select it again so it's highlighted. You can see I'm going to output it to see NIST26 MS search because that's where all my libraries are kept for searching. And this at the bottom shows that I want to export it or really actually format it into NIST MS library. And all you have to do is say convert. That takes about 17 minutes to do, and I will not do it again. I've already done it before I started the demonstration. So this is pretty much the process. It is as simple as that. So we'll just exit out of this since we've already converted it. So now it's done. To test it, we'll go to the NIST software and see if we can find it. So we'll go up to the libraries and see if it's there. And it should be Mona all LC-MS orbitrap. So you can see it's here. And I've clicked to say add, and I put it at the bottom. You can see that's our 159,463 spectra in one library. Well, also go and add it to the structure search. You have to specify for structure search which libraries you want, and it will be in this case the same thing. So we have that selected. That's good. Okay, let's go back and look at our settings though. Initially, we're going to do an MSMS with a precursor where you specify the precursor to see if it works. And so we'll do that. We'll do the same filters I normally use here. The libraries we've already selected and automation is on all the time. So that's set up now. So I have a spectrum here of a component that's in here. I imported this from Mass Hunter into the program so I could test it. You could have brought it over from the chromatogram here by running this forensic tox test mix and use the chromatogram to process it and then select it and say library search. It'll go over to the other side and you'll see that it searched fine. We got the right results here. Everything's at the top. Here you can step through them if you want to using the arrow keys on your keypad. And up at the top is our unknown. The bottom's the library hit that's selected. So that worked fine. If you didn't want to have all these duplicates, I like to see them initially. You can come up here to say best matching only. And the next one will be something different. It uses the Inchy key, which is a representation of the structures. You can see at the bottom right here, here's a typical Inchy key, somewhat like an ASCII formatted way to represent structure. I will turn that back off. Also, there's a filter here that I don't enable very often either, so make sure that's off because it'll affect what is displayed. It doesn't affect your library results for either of these, but it does affect what is displayed. So that works fine. We'll go try a different search now. We'll do the MSMS. This time we will do high res, no precursor. So the other one requires it to have the same precursor and then match the spectrum for the MSMS. This one says I will just match by a pattern and I will not specify that it has to have the same precursor. So we'll say OK. And to search that spectrum again, you can double left click on it or you can just click go. And you can see again, we got trazodone here. If you want to know what type search you did, look at the bottom here, high resolution, no precursor, displayed, high resolution, no precursor. One other setting that I didn't mention up here when I was setting up the MSMS, we're doing full spectrum search score with the default pre-search. The pre-search allows the searches to go much faster, so you always want to have that on. And you can always see what the pre-search yielded up at the top. It shows the precursor. In this case, we didn't specify one. And shows how many spectra are in the final hit list where it searched the whole 159,000 and it narrows it down to 100 to finally calculate the best match. Let's check another type search. This is a way that I use sometimes if you want to mix and match high resolution with low resolution spectra, libraries, etc. It says EI normal, but it really just searches nominal mass and it lets you use all of your libraries. So I find that useful at time. And it's really just a pattern match, but it doesn't restrict you to using only high resolution libraries or high resolution imported spectra. If you're on a MSD and you brought it in from in source where you didn't have accurate mass, this is very useful. So we'll try it to make sure it works. Again, double left click or go, and that worked again. Okay, very good results. One last thing, we need to do a hybrid search. Now we select similarity and we'll choose MSMS hybrid and we'll have the precursor because we do have a precursor in here. You can look up at the top. It knows what the precursor is for this. It's the 372 parent ion there. So it knows what it is. And we'll say OK and say go. And now you can see at the top, pre-search default, knew what the precursor was. At the bottom, it tells you we're doing an MSMS hybrid. And I can't really explain a hybrid. It's somewhat complicated, but it's very, very valuable. You need to learn how to do hybrid searches, and it is imperative that you make sure that your libraries work in hybrid mode because it's so useful. You can look at the bottom, it does other parameters that are not shown up in a standard search. And again, you'll have to study a little bit about hybrid searches. So one last test to make sure everything works. When you come in, you have to rebuild the structure search databases. Well, I've already done this in this case, but I just want to show you where it goes to. It showed up on the other screen. I'll drag it over here. And normally when you come in the first time, right after you convert it, this will be in lowercase. And it says libraries in uppercase are probably up to date. So if it's in lowercase, and it would have been after I did the conversion, you would have to select that and build. I could build again, but I've already done this. If you don't do that, you can see the structures when you get your search results. However, if you try to do a structure search, it will not work. And as I mentioned before, in structure searches, when you set up your libraries, be sure that you define spectrum search and structure search. So let's do a structure search. To get that, you have to get something in as a structure. So you can right click on anything you want that has a structure. So this library entry has a structure, and we'll say copy structure to clipboard. Well, it'll actually just go ahead and copy structure to clipboard. Then you can come up here and say insert clipboard structure. Now you'll see at this entry at the top, usually we have a spectrum, but here we only have a structure to search. So we come up to this three-membered ring and you'll see it says structure search and go. And you can see we found trazodone and it's rated on 1,000 fit is perfect. So, and you can also find model compounds that are similar to trazodone by this approach. So, I hope this video has been useful to you and you can apply it in your work to use some of these public libraries, which offer some additional entries that are not in the NIST library and vice versa. So it's good when you know what you need in your work to go look and find a public library that has things of interest in it to you. And also you need to create your own user libraries because even though they're small, they have things that are of keen interest. There was one last critical thing that I forgot to mention. That is when you're in lib2nist, we've already selected the SDF file that we desire to convert. You need to go down in the options and make sure that MS-MS Spectra only is selected. I think this is particularly important for MS-MS because it restricts the number of spectra that you can convert. If that's not on, that's more appropriate for EI, and I think there's only 65,000 you can put into an EI or such number, but this allows to do the much larger numbers that are needed for MS-MS library conversions. So again, I hope this video has been very useful to you in your work. Good day.